data races and Swift6, changes in SwiftUI, and how to fix slow compile times. I'm Alexander Belous, an engineer at ZTAP, and we are diving into the hottest iOS and macOS updates today. Before Swift6, developers had to manually ensure data synchronization during program execution to prevent data races, a conflict from unsynchronized access to memory by multiple threads. Protecting against data races is a non-trivial task in terms of implementation and long-term maintenance. Moreover, identifying the need for state synchronization is challenging, because problematic code does not always lead to errors during execution. Starting with Swift6, data races checks occurs at the compilation stage. The data isolation mechanism ensures safe access to the program's mutable state. So, if you have synchronization issues, you will see a hint during a project compilation. However, full data race safety requires support by all third-party dependencies. That's why Swift Package Index now includes information about Swift6 support and thread safety of packages. Unfortunately, after testing all available SPMs on the site, only 1,500 are free from data races, while over 70,000 have diagnostic errors. Apple introduced changes in SwiftUI, updating APIs for building interfaces and UIKit. Starting with iOS 18, views automatically track UI trait in various methods, including layouts of views, update view constraints, draw, and others. Now you can forget about duplicating code associated with registering UI trait observers. Also, the new UI update link, similar to CI display link, helps update the app interface predictably and promptly, supports low latency mode, and enhance energy efficiency. UI update link is associated with UI view or UI window, activates automatically when they appear on the screen, and deactivates upon removal from the hierarchy. I particularly liked that when UI view is moved from one display to another, the refresh rate of UI update link adjusts automatically. Adding animations to projects has never been easier. Starting with iOS 18, SwiftUI animations are available for UI view. The simplicity of API will allow you to effortlessly enhance your app's interface. Compilation time for some expressions can be absurdly long. Chris Lattner, a former Swift developer, discussed the complexities of the existing compiler, which uses the Hindley-Milner type-checking system. While this system allows minimizing syntax, it generates two problems: slow compile times for complex expressions and unreadable compilation errors without context. Let's consider an example with concatenation of string values where one parameter is numerical. On my MacBook M1, compilation took 50 seconds, after which I received an error. The compiler cannot check this expression in a reasonable time. However, simply converting into string and the compilation of the expression takes only a few hundred milliseconds. Slow compile times is not a new problem. The official Swift repository includes documentation on how to diagnose, localize, and improve project build times. For the simplest solution, you can use compiler flags, var long expression type checking, and var long function bodies to identify expressions and functions exceeding the specified compile time limit. After that, you just break it into smaller components. And how do you reduce compile times? Share your tricks, project build times in the comments. Great news for those who love building graphical interfaces exclusively in SwiftUI. With the new navigation transition protocol, you can now create hero transitions between screens in the style of the App Store. The API offers automatic and zoom animations. For the zoom effect, namespace and ID are used to associate interface objects. As a result, you get a mesmerizing effect during screen transitions. For those who prefer alternative development environments, VSCode has improved Swift support. Now, alongside XCTest, it supports the new Swift testing framework, which my colleague Roman discussed in details in a previous episode. Test coverage functionality has also changed, now displaying results in a test explorer. VSCode also added the ability to rename symbols in a global context, fully compatible with Swift patterns and supporting cross-language specific of C, C++, and Objective-C. Now, SourceKit-LSP supports integration with Swift format and indexes project in the background. No need to build the project to update the index. And finally, with support for the Swift6 toolchain, VSCode has migrated from code LDB for debugging to the LDB-DAP adapter. That's it for today. If you want to learn more, all the links will be in the description. See you next time.